Okay, I think we should get started very soon because I'm quite optimistic today. So I added a few more slides than I should have. So I think we might have a lot to talk about towards the end. Um, I'm not sure if Joris has joined, but um, but it's really not necessary. So I'll take it over, and then maybe whoever wants to join can join a bit later as well. So first of all, am I audible? Is there any issues in seeing the screen or hearing me talk or something of that sort? Okay, great. Thank you. So yeah, I'm sharing the screen, sharing my entire screen. So you might see some black spots here and there. But since I had some URLs that I wanted to access, I want to share my entire screen rather than sharing just a presentation. So I hope that's okay. So, okay, so let's get started very soon. So basically in today's methodology class, I'm going to talk about behavioral research using secondary data sources. So you probably know what behavioral research is. I'll also give you an introduction to it, but maybe secondary data is a new term that you've come across recently. But secondary data basically means any data that has been collected and it exists for researchers. It exists and can be used by researchers. So in contrast, primary data is collected by the researcher for that particular research. Secondary data is not necessarily collected by the researcher and is not necessarily for the research itself. So that's the main difference. But methodologically, the approach we use is also a bit different, and the robustness that you need to some of the robustness checks you need to do is a little bit more exhaustive when you're dealing with secondary data sources because you do not know who's collected it and what's going on with it. So you should be a bit more careful when you're dealing with secondary data analysis. And we'll talk a little bit about the challenges and considerations that we have when we consider secondary data sources. So without further ado, let's get started. So today I have four basic things that I wanted to cover. In the first part, I want to just introduce behavioral research to you. I know I'm going to repeat a lot in this section, but I think it's useful because we can position how behavioral research fits into this whole gamut of IS research. So let's start with that. I'll also talk about some of the considerations of behavioral research, some of the behavioral research design concerns, and how and what involves behavioral research methodology. So in the second part, I will go into data collection and measurement. I'll go very quickly. I was hoping to spend a lot more time with data collection and measurement, but I realized it's just a part of behavioral research. So I'm going to go relatively quickly. And if you want, we can just talk about it in some future session or in some future meetings. In the third part, I'm going to talk about modeling and analytics. I'm going to focus only on one approach, that is regression, because it's the most commonly used approach in behavioral research. And the reason why it's most commonly used is because it's well understood, and all the assumptions and all the challenges in using regression are well understood. And so it's easy to check if the research is robust or not. In fourth part, I wanted to give you an illustration of one of the research questions that I had handled. It deals with understanding the implication of access restrictions in open source software development. I'm not sure how much time I'm going to have for the illustration. In case there is time, I would love to cover it. If not, the slides are there and it's self-explanatory, so you can just go through it at a later point in time. So let's get started with the first part, okay? Behavioral research design. So let's first position behavioral research in this whole gamut of IS research. So first of all, behavioral research deals with creating new knowledge or new understanding. So, and how it does that is by developing and verifying theories that exist in the discipline. So for example, a very interesting behavioral research question would be something like this. How does university grades impact future wages? It is a very interesting question, but it's also very relevant, and it's relevant for the discipline of labor economics. So these are the kind of questions that you generally come across when you're dealing with behavioral science research. In contrast, design science is a lot more utilitarian. It tries to create new artifacts, sometimes using what is understood from behavioral science, and with the whole purpose of solving a particular problem. So a research question that is seen in design science looks something like this. How can you design a customer-oriented chat box for a Dutch Housing Association, for example? Design science, you have already had an introduction, and in the next session, Professor Emile Caron is going to deal a lot more into design science. Behavioral sciences is probably your first methodology course, but you'll also have one on survey methods and one on positivist case studies as well. So let's move on. So what are the key components of behavioral research? Well, there are at least three components when it comes to behavioral research design. Notice I'm using the term design. Behavioral research methodology is the second part of it. By behavioral research design, I mean the front end of the research. That is in terms of creating a research question and setting up certain hypotheses to be tested. The methodology is the back end of it, wherein you use analytical models to test the relationship that you have created. So for behavioral research design, there are three important considerations. The first is the research question. So the research question, as I said in the previous slide, the whole motivation is to try and create a new knowledge or new understanding. Usually questions which start with why and how relate well to behavioral research questions. So the question that I introduced last time, how does university grades impact wages, is a very typical behavioral research question. When it has two important aspects of it. It is very interesting because it's not very well known. We do not know the exact effect of university grades on the actual wages. So it is an interesting question. And it is also relevant because labor economics has a lot of theories about impact of incentives and impact of education and skill sets on wages. So it's very relevant for the discipline of labor economics. The second important component of behavioral research is the theoretical or the conceptual model. A theoretical model is basically a set of concepts and their relationship. By concept, I mean general or abstract ideas that occur in a thought. So, for example, if someone says, what is a four-legged thing that moves around? It has a head, it has a tail, and it has pointy ears. So in our minds, we have conceptualized this as probably a cat. So the conceptualization is very ingrained in our thought and in our mind, and it can create certain it can take abstract ideas and create concrete things out of abstract ideas. So in our example of university grades impacting wages, the concepts that we have are university grade and wages itself. These are the two concepts that we are kind of covering over here. So you might ask, what is theory if the theoretical model is a set of concepts and their relationships? What is theory? Theory is nothing but a theoretical model along with some understanding of the meaning of the relationship. So when you add why to those relationships, you take a theoretical model and create a complete theory out of it. Of course, it's a very short description of what a theory is. It's actually a lot more complex, but this is a very simplified version of what a theory is. So finally, we have the third component, which is the hypothesis. The hypothesis is a proposed explanation of a phenomenon. It is more often than not a testable statement. So when we say, when the research question is, how does university grade impact wages? then a hypothesis coming out to address that research question would look something like this. Higher university grades lead to higher future wages. So this is a statement which can be tested. We can test whether actually an increase in grades leads to an increase in future wages or not. Notice there are two important things that came into the hypothesis. One is known as causality. I stated that university grades impact future wages, and it's not the other way around. It's not future wages impacting university grade. We have a clear cause and effect relationship, and hypothesis needs to test that causality as well. Another important thing hypothesis establishes is a context. So it kind of tells you where it's applicable. So when I say university, so you know I'm not talking about high school or anything of that sort. I'm talking about bachelor's or master's or something like that. Of course, the context could be made more specific or could be made more general, depending on what kind of contribution you want to make back to the theory or not. So when you create the hypothesis, you have this nice theoretical or conceptual diagram that you have. You have university grade, which is a concept on the left-hand side, and you have which is the cause, and you have the effect, which is the wages. And there is a relationship as well. There's a positive relationship that increase in university grades implies an increase in future wages. By the way, if you have any questions, please feel free to either talk over me or ask over chat. Or if you want to wait for a particular break or something of that sort, that also works. So feel free to interrupt or type on chat. So there are some important consideration when it comes to behavioral research design. I'm going to talk about these considerations very quickly. They're actually very, very deep concepts, which uh, the time does not do justice to the concepts that I'm introducing right now. But it's very important to know what these are. And because in future, if you take up behavioral research, you will hear about this more and more. I got a question saying, does the thesis have to be exploratory research? Well, any research, I mean, the term exploratory, I'm not going to use the term exploratory because it takes a new different meaning. It means it's not hypothetical deductive, it's something else. So I'm going to eliminate that. I'm going to answer the question, does the thesis have to generate new knowledge? So, well, ideally, every research needs to generate new knowledge, but generating new knowledge is a kind of a subjective term. So the way you can do it is by three ways. One is by addressing some unknown. You notice a gap in literature which is not addressed yet. So that gap could be addressed, and it could still constitute as generating new knowledge. And a new gap could be quite easy to find. Suppose you have a theory that is developed for the context of in labor economics, like just I talked about. Increase in university grades impacts increases the wages. So and there is already literature, and there is theory, and there is research that tells us yes, it's true, and there is a positive relationship. Now, how you can build a gap out of this theory? This theory is by saying that you know what, this research looks at university grades, but they have not looked at say specifically master's grades or specifically high school grades. So what you're doing is you're taking a theory that exists in one context, and you're re-looking it from another context, and that is still that still constitutes as generating new knowledge. Otherwise, it could be otherwise you could find literature that talks contradictory things. You start by saying that, you know, I have these two theories which say, or which if we apply it on this phenomenon, it will give two different results. So let me try to figure out which of them is correct. So you can see if there are mixed results in theory, and try to figure out which of the results are true. That also contributes as new knowledge. The the third very tough one, but very, very good one, is by challenging one of the assumptions that exists in theory. For example, for a long period of time, economics was dealing with the assumption that human beings are rational. So then, at some point, people started realizing, this very important assumption is not really valid. And then you had this huge set of behavioral scientists who got involved, and a huge discipline came about just because they challenged that one assumption that existed. So these are the ways you can generate new knowledge. So to summarize, yes, any research, if you want to do a good research, you need to generate new knowledge. But does your thesis has to generate new knowledge? I do not know. It's up to your advisor and the secondary reader. But if I'm a secondary reader, I would look for what new thing you're trying to find. I hope that answers it. Kind of a long answer, I guess. But anyway, so let's move on. So next is I get another question. Okay, thank you. The important considerations are, so let's look at the first consideration. Again, I'm going to go very quickly. These are very, very deep concepts, but for the time being, it's sufficient to know that these are important considerations. And at a later point in time, you go a little bit more deep into it. The first is the causality of relationship. Already I introduced what does causality mean. It means establishing what causes what. And why is this important? Well, it's important because it is necessary to explain a phenomenon. If you do not establish causality, all you're doing is describing a phenomenon, which is not generating new knowledge. It's creating maybe a new understanding, but generating a new knowledge requires understanding why what you see exists in the first place. And that requires understanding what causes what. So how do you find causality of relationships? Causality of relationship. Now, the best way to find it is through experiments. These are experiments are kind of a gold standard for establishing causality, and that's why they're used when it's most important. For example, there is a lot of drug testing going on, especially with COVID vaccine, and the way they are doing it is these lab testing are all lab experiments wherein they find out of a population, they randomly sample a group of volunteers. They randomly split the volunteers into two groups. One is called the treatment group, and the other is called the control group. The treatment group is given the vaccine, while the control group is given a placebo of the vaccine. That means a vaccine without the active ingredient. Now the experiment involves studying what happens to these two groups and comparing these two groups. If the treatment group shows a significant positive effect, whereas the control group shows a very minimal positive effect, we can say that the drug has some positive influence or not. So notice I talked about two important things that makes experiments so good at bringing out causality. One is the fact of random sampling, and the second is clear identification of treatment and control groups. So when we look at behavioral research, how can we replicate an experiment? It, it's not very easy, but through really nice novelty and really good thought and very good design, you can actually replicate experiments in behavioral research as well. So let's take the example of influence of university grades on wages. So how can you do an experiment here? One way you can do this experiment is, suppose in the university there is a cutoff grade after which the students who do not meet the cutoff grade needs to drop out of college. What we can do is we can take all the students who are not reaching the cutoff grades, and then randomly sample a treatment group who are allowed to progress despite not meeting those grades, and another group are not allowed to continue, and they become the control group. And then we compare what happens in the future. So this is a good experiment, good behavioral research experiment. But of course, you see a huge issue in this. First is, of course, the ethical issue. Who wants to be in the control group or in this? And is it even right to have a control group in this experiment? How can you deny people? How can you allow some people to progress while the others not to progress? And the second thing is, it's also time consuming and very hard. Like wages do not come very quickly. It comes over a period of time, and there could be other issues that happen between graduating from college and getting their first wage. So you never know. So even though you can create experiments, it's not very easy to create experiments in behavioral research. So what do you do if you can't create behavioral experiments in these settings? Well, the next best thing is to go for observational or secondary data, or in other words, data that has been already collected, that exists, that has been created for some other purpose, but can be proxied for the concepts that you are studying. So for example, in the case of university grades has a positive influence of wages, we can do an observational study. We can figure out university grades by looking at transcripts, by asking the university to give them the transcript sheets and so on. And then the wages can be of past students. And then the current wages can be figured out through certain websites like Glassdoor, or if the country has a policy of giving all the income out, so you know the income of each position and so on. So you can find these proxies to estimate university grades and wages, and you can try to figure out if there is a positive relationship or not. But when you're dealing with observational or secondary data, notice that you can't really do random sampling, and it's not very easy to identify treatment and control groups. So what this means is there is going to be a lot of confounding factors that could actually mimic the relationship that you're studying without the actual relationship being existing. So for example, suppose you do this beautiful observational study and you find that university grades has every point increase in university grades has, say, 250 euro increase in wages. So you find this using observational data and you're really happy about it. But can you trust these results? It's not very easy to trust these results because there could be other confounding factors that have created this relationship to exist. For example, there could what the relationship could exist simply because some students are coming from having a different background than the others. For example, if your parents' income is higher, the chances of you getting a higher university grade is probably greater. The reason being, at home you have more facilities and you have more kind of encouragement to pursue your university grades. In similarly, the same effect could lead to higher wages because the parents may have their networks and might help you get better jobs and better paying income. So the existence of parent income can confound the relationship, and students having parents greater students with greater income parents would have higher grades and higher wages, and students with lower income parents would have lower grades and lower wages. And if you do not keep the parent income constant, you will see the existence of the relationship even without the relationship actually existing. So what do you do when you have these kind of confounding factors? Well, the most important thing you need to do is to keep them constant in your models. And how you do that? Well, you include something known as a control variables. I'll talk a bit about control variables in the next few slides, but that's how you do it. The other way to think about it is, is there some sort of a natural experiment that can be used to mimic an experimental setup? For example, if a university is shifting locations from one location to another, it's a really nice natural experiment, because especially if the location choice is very random. And you can use these kind of small changes in policies and small changes in like external circumstances to create small natural experimental settings. So the fourth important consideration is the statistical model and inference. Every statistical model is based on certain assumptions, and they are valid only to the extent that the assumptions are valid in your data. So the fourth important consideration is your population, and is the distribution in your population following the assumptions that the statistical model requires. So for example, if you do a linear regression, you're making the basic assumption that the outcome variable and the income variable are related linearly. That means you can fit a straight line that relates the outcome variable, which is the main dependent variable, and then and the predictors or independent variables. But if the relationship is not linear, you're going to have a few issues with the actual causality and the actual effect size that you measure. So these are the four main considerations. It's very brief, but you'll hear about them more and more. And as you pursue your research, you'll need to spend more and more time understanding them and trying to deal with them. So next is behavioral research methodology. So first, up till now, we were thinking about behavioral research design. Now let's assume that the design has gone well. You've created your hypothesis, and you've figured out where you're going to collect the data from. So the next aspect is the methodology, implementing the behavioral research. So there are three main steps in behavioral research methodology. The first is data collection, figuring out where you're going to get the observational data or secondary data, and actually collecting them. I'll talk a little bit about them in the future slides. The second important thing is measurement. Once you've collected the data, you need to convert your concepts to measurable variables. So for the thing is, the concepts you need to figure out proxies or appropriate measures that mimic the concept that you want to measure. For example, in our research, we say that increase in university grade has a positive influence on the wages. So the main dependent variable or the outcome variable is wages in our case. We can get this from certain sources like Glassdoor, or it could be public data by itself. You can also use LinkedIn, for example, to figure out what is the position of the person, of the individual, and then figure out how much the position on an average pays. In the same research, our independent variable is the grades, university grades or educational qualification, which could come from different sources like your CV or university record or so on. And the third important thing is the confounding factors. Or last time when I was talking about the relationship, I said that parents' income could be a confounding factors and hence must be kept constant in our model. But there could be other things as well. For example, location could also be an important confounding factor. A certain location might have greater access to universities and might have better universities than other locations as well. So they could also influence your wages and without the relationship existing. So you need to identify all the confounding factors and try to control for them or keep them constant. So the third important step is modeling and analytics. And when you're doing your modeling and analytics, you will come across three important challenges. The first one is the identification strategy. Identification strategy is the manner in which you're trying to make your observational research as close to a real experiment as possible. So there are different ways you can do that. One way is through natural experiments by looking at certain events or external shocks that occur in society and studying what happens before and after the shock. Natural experiments are really good because they are often random. Take COVID, for example. Who expected COVID to happen? And suppose there is someone interested in understanding if online teaching makes sense or not. Does online teaching equate offline teaching? This is the best experiment that you can have. No one expected online teaching to become the norm. And so before COVID and after COVID, you can run tests, you can identify appropriate control groups. Control groups could be identified from other countries, for example. India is still following offline teaching right now. So you can see if there is a change in grades in India versus change in grades in Netherlands, for example, and you would know whether online, and it's probably going to be because of the shift from offline to online teaching. The second important modeling aspect is the model type. There are several models available for you, but I will talk about just two: cross-sectional models and longitudinal models. Cross-sectional models involves observational data that is taken at a specific point in time. So for all individuals, suppose we measure wage at a specific point in time and university grades at a specific point in time, then it's cross-sectional models. In contrast, suppose we uh, we measure it over time. We can have multiple observations of the same individual every month or every year or every 5 years or something like that. And then you have something known as longitudinal or panel data models. I'm not going to go very much in detail into it, but just keep in mind cross-sectional models are not very robust because it's very hard to figure out all the confounding factors. How will you know what are the issues what are the control variables you need to include? Longitudinal models, on the other hand, are a lot more robust because it's very easy to control for all time invariant confounding or control variables. I'm not going to talk too much into this. When you pick your models, you'll always read into it and you'll figure out which is the appropriate model for you. The third part is the analytics part. So finally, regression. I'm going to talk mostly about regression. Regression is a predictive modeling technique wherein we try to find a best fit equation that relates an outcome variable with its predictors or independent variables. I'll talk a lot more about regressions in the future slides. So if you want a reference, and if you maybe it's not necessary at the level of master thesis, but if you want to take behavioral research further, this is a really good book. It's called Mostly Harmless Econometrics. Even though the names sounds very nice and very easy, but it's a tough book to read. But it covers everything that you will ever need to know about building a very good behavioral research. So okay, so let's move on to the first aspect, which is data collection and measurement. And then I'm going to talk about modeling and analytics, and then we'll end with an illustration. So meanwhile, if you have any questions, you can just ask before I move on to the second part. Okay, check the chat. Okay, thanks. So yeah, I think there are no questions. So okay, I'll move on. But you can feel free to stop me whenever you feel like. I might be moving a bit quickly, but just remember, even if it passes over your head, it's fine. It's important to know that these concepts exist first, and that's the whole purpose of this presentation, to show that there are these components, considerations, and so on. And as the best way to learn any sort of research method is by actually doing research, making mistakes, and learning from your mistakes. So right now, it's important to know the concepts, and it's important to know where you can go wrong. And as you pursue your research, you learn more and you try to correct your mistakes as well. So let's first look at data collection and measurement. So first thing is, when you're doing behavioral research, the first question will probably come is, where can I get observational data? Well, actually, we are very privileged these days because there's plenty of data available for us, and most of them are given to us in like a platter, in a silver platter, which is easy to consume. So the first case is public databases. The concept of open data and the movement of open data is really picking up steam. Everyone feels data should be made available for everyone rather than being private and available only for a few people. So you have a lot of databases and archives which are maintained by individuals and organizations. You do a simple Google search, you'll probably find a lot of databases that you need. A specific note I would give to Google, because this is a really nice public database that I have, that I sometimes use, and it has some really fun data. So for example, it covers data like the COVID-19 public data sets. It has crime data, it has birth data, it has a lot of Bitcoin and cryptocurrency data. So it covers a lot of information, and it's very detailed and very deep. So it's a nice place if you are searching for data. So that's one example of a public database. Um, then you'll ask the question, how can I access these public database? Well, it depends on the database itself. Sometimes it's very simple. All you need to do is download an Excel file equivalent of the data, and it's very easy. It's ready made for you to run and analyze. In some cases, you have to run some basic SQL queries, and in other cases, you'll have to programmatically get the data using something known as an API or an application programming interface. These are public databases, but you also have a large amount of databases provided by the library. So if you're if you notice there is some database, but it's private, you need to pay for it. Check with the library. They have a really good list, and some of the most popular databases like the WRDS or the Wharton Research Data Services is made available for everyone in the library. You can ask for a login and password, and you can access this database. And WRDS has this nice database called CompuStat, which has the database of financial, statistical, and market information of global companies. So if you want to study the performance of IT companies, if you want to study the impact of something on the performance of IT companies, CompuStat is a nice place to begin with, because you can select IT as your industry, and you'll find all the companies all global companies that belong to this category, and you have the financial statements of those companies. It's also a good idea to combine databases. Sometimes you have this really nice relationship, a really nice and complex relationship, and all the variables may not be found in one database. So you might need to compare them. You will need to find certain IDs through which you can match the database, and then you combine and do your research. So suppose you do not have, what is the other place? One is databases, wherein the data is well curated and is meant for research. So suppose you want to go beyond that. You have relationship, like say you want to study the impact of some CIO's tone of language on something on the performance of the company. The performance of the company you can get from CompuStat, for example, but how do you figure out the tone of the CIO? Well, the good thing for us is this huge amount of social media data that's available to us. So the tone of the CIO can be approximated by checking their tweets or something of that sort. You can just collect all the textual information about the tweets, and then you do some textual analytics, and you can try to figure out what is the tone of the CIO. So where does the tweet exist? It exists in websites, and so data collection. So this kind of data collection involves some amount of usage of web data methods. So when you're looking at data that is on websites, you're faced with two kinds of data. One is structured data. Structured data is nothing but very predictable data, and it has this nice tabular format. So the best way to think about structured data is it looks like an Excel sheet. An Excel sheet has these column headers that define what each column contains, and it also has row headers, which tells you what each row should contain. So for each cell in a Excel sheet is well identified, and you know what it actually means. The column headers and the row headers together are referred to as metadata, or data about the data itself. So structured data has metadata, and it is tabular and predictable. But often websites are not so structured. You do not see websites as tabular or as a tabular sheets, but you see them as these colorful and very integrated documents with music, with pictures, with videos, with JavaScript, with small games, with small ads, and so on. And it's often very unpredictable. It's you do not know where the picture is going to exist. In one website, the picture is in the middle. In the other, it's at the bottom somewhere. So it's while websites, the format that is used to create a website is called the language that is used to create a website or write a website is HTML. So while HTML websites are very easy for humans to understand, it is not very predictable and hence not very easy for programs to understand, and it's not very easy to do research with to begin with. So let's look at a website. It's very pictorial, as you see in the bottom left hand of the slide. It has a lot of images. It has a lot of information as well. So what is a structured equivalent of this website? The structured equivalent of the same website would look something like this. It has a nice dictionary format, or you can even call it a tabular format, because I have metadata. I have data that defines what each data mean, and then I have the actual value of the data itself. So let's look at unstructured data a little bit more. I will go very quickly now. If you want to cover this in a little bit more detail, if you want certain small Python scripts to start working on collecting unstructured data, please reach out to me. I can try to get you started at least. So first is let's deal with unstructured data. You have websites which are easy for humans to understand, but are often unpredictable and unstructured. So the reason is there are a lot of these pictures, a lot of ads, and a lot of extraneous contents that makes everything a bit complicated. So the process that you use for collecting unstructured data is known as web scraping. And web scraping has two parts. One is the crawling. Crawling is the process of going through the website from one URL, skipping from one URL to another to locate the specific information that you need. It's mainly used for archiving and indexing, and the most famous crawlers are the search engine bots. So the Google bot, for example, is the biggest web crawler that exists. It is constantly indexing the website so that the search can be optimized. So once you have figured out a way to crawl through the website and you have figured out a way to locate the information that you have, the second part is extracting the information from the website. This part is not as simple as you think, because each website is written by using the HTML language, HTML, XML, CSS. It's a mix of many languages, but these kind of pages while they're easy for humans to understand, when you look at the actual script of the website, it looks like gibberish. So it's very hard to programmatically extract the specific information that you see on a website. So I'll give you an example. So let's I'll go to I'll go to a website called github.com. github.com IBM. So this is basically github.com is the place where almost all open source software development happens, and this is a page of IBM's open source software projects. So while it's very easy for us to understand, let's try to collect one specific information, that is the location information of IBM. So if I need to find it, I need to see how Python or any program reads this location information. So if I right click and I press on inspect, I get the HTML source code of that web page, and I see that I see the exact place where the location exists in the HTML page. It exists in a tag called span, and within a class, and within a UL class, within a division within another division called table object. So by using specific, the Python program will read the page like this, and by just checking these tags, you can find the specific information that you need. The problem with unstructured data and HTML data is now, suppose I move to another site. I'll go to Google's GitHub page. If you notice, there is no location information. And suppose you've written this Python script to scrape the data and you've figured out the location of IBM. When it shifts to Google, you do not find it. So unstructured data is a bit hard to handle, but if you need to handle it, you use something, you have to scrape it. So let me go back, okay. So it looks something like, so basically, if the web page looks like this, the HTML equivalent or programmatically for Python, it looks something like this. And you need to search these tags to figure out where the content that you want is located. In contrast, suppose the website is making it easy for you. It can give you the data in a structured format. So first of all, why should website give you the data in structured format? Well, in many cases, it's not only users interacting with a web page, but also applications. So GitHub, for example, has a lot of applications built on top of it to provide services to users. And it encourages these kind of applications. So the best way to encourage these kind of application is to provide data in a format that is very easy for applications to understand. And that is by giving them very structured information. So API, so basically, if a website wants to make it easy for you and wants to give you structured data, it gives it to you through something known as an API or an application programming interface. Notice this contrast. You've heard of user interface. User interface is something that is basically an interface between a user and a program, or a user and an application. In contrast, an application programming interface is an interface between one application and another. So it's one Python program interacting with some HTML or Java program. So, so if uh, uh, if the website wants to make it easy for you to programmatically collect data, it will give you API services that makes it easy for it. So how does this API services look like? It looks something like this. GitHub offers this API services, and the same data, the API data can be accessed through unique URLs which are referred to as endpoints. Uh, so using those URLs, you can find the same data that you saw, uh, the same HTML data that is well curated and well accessible for you. So notice over here, you have the location, which I was searching for by scraping. But if I use this API service, it's very well structured and very easy to locate. So this format of data has a name. It's called JSON format, JavaScript Object Notation. And in contrast, a website is built on HTML, language. APIs are built on JSON languages. They're easy for not only users, but also are easy for programs to comprehend and understand. So this is the same website, and this is how the website looks like when it's accessed through APIs. So we can take a short break. I think the time is right for it. 45 minutes, yeah. So if you have any questions, stay back, and if not, let's take like a 6 minutes break and get back at 1:40. Is that okay? Okay, welcome back. I hope you could have a nice break in between. Um, Meanwhile, if you have any questions up till this part, please feel free to ask, and I'll get started in a minute or so. Okay. So yeah, again, if you want to stop me, just stop me when if you have any questions. If not, we can just take it even at the end or even offline as well. So, so up till now, what all we have looked at two particular things. We started with understanding what is behavioral research. Behavioral research has, I mean, the first is we looked at the behavioral research design, some the key components of it, and then some of the key considerations. Then next, we looked at behavioral research methods, and we started slowly getting into the depth of these methods. First thing we looked at is data collection and measurement. Measurement was, of course, very brief. The second we will look at the analytics, modeling and analytics part. Here, I'm going to cover just one thing, that is regression. There are several modeling and analytical techniques, and there are several within regression itself. There are several types of regression, and there are several different ways to do it. So, but the reason why regression is so popular is because it's very intuitive. It's very easy for us to understand, and very easy for us to understand, and very easy for us to validate. The more complex the model you build, the harder it becomes for us to validate it. There'll always be something going on which we just can't see, and we just can't understand. But in case of regression, we know most of the issues that can happen. So it's a good way to run it, but it also leads to the challenge that we know all the problems in regression. So when you run a regression model and you submit it to some conference or something, they will be able to identify some of the common issues that the regression is facing. The term regression itself came from biology. It's somehow, I feel it's a very dark beginning that it had. There was some anthropologist or biologist who was trying to figure out if the height tends to decrease over age, over years. Tall ancestors would eventually lead to uh, short children or something of that sort. So, and they were calling this regression, regressing to the mean. And of course, the term itself, we know it has a very bad connotation right now, but it originally started with that kind of this biological research. And now, of course, it's very popular with behavioral research, and it's quite a powerful tool. So regression deals with here we try to investigate the relationship between the dependent variable, which is the outcome, and the independent variable, which is a predictor, by fitting by f- by f- by trying to fit a mathematical equation that clearly relates the independent variable with the dependent variable. So for example, if we say that higher university grades lead to higher future income, the dependent variable we are concerned about is higher future income, and the independent variable or the predictor is the university grades. And we'll try to fit a mathematical equation that relates future income and university grades. So there are two important considerations. The first consideration is the type of dependent variable. In our case, future income is the main dependent or outcome variable. And it is the type of our dependent variable is it is a continuous variable. That means it can take values like 0, 1, 2, 3, and so on. On the other hand, it could be also discrete. For example, if we say, does higher university grade result in employment? Then the main outcome or dependent variable would be whether someone has a job or not. And it has only two values, 0 or 1. So Depending on the type of dependent variable, our choice of regression models also change. For continuous models, you have linear, logistic, polynomial, multinomial models, and discrete becomes a little bit more in terms of logit, probit models, and so on. But in every instance, remember, we are always trying to fit some mathematical equation or the other. We are starting with an understanding of what the relationship should be, whether it's a straight line, whether it's something else, whether it's a logarithmic line or something, and then we are trying to fit that line onto that as a relationship between the dependent and the independent variable. The second consideration, of course, is the shape of the line or functional form. That is, what is the relationship between the dependent and the independent variable? In some cases, it's very simple. We can make the assumption that they are linear. Higher grades results in higher future income linearly. That means if a grade increases from uh, C to B, and the resulting increase in future income should be equal to the increase when the grade increases from B to A. Of course, this is not a very realistic assumption because almost no relationship is purely linear, but it's an approximation that you can make in most cases. That you can just say, let's assume that it's a linear relationship and start from it. If you do not believe it's linear and you prefer and you know for sure it's something like a logarithmic relationship, that means it tends to taper off towards higher grades, then you can fit a more logistic kind of a relationship. Similarly, it could be exponential, it could be inverted U, and so on. So the figuring out the functional form and shape of line is often referred to as parameterization. Uh, in contrast, if you have certain machine learning methods, they're non-parametric. That means they do not restrict a functional form. They do not start with the understanding that there is a functional form. All forms are infinite possibility of forms exist, and they'll try to figure out what is the best option. So let's look at linear regression a bit more. In most cases, linear regression is sufficient for behavioral research because you are more interested in the cause effect. And linear regressions are often sufficient to establish this cause effect. If you are more concerned about effect size, if you want to see the actual amount of change over time, for example, then you would need a bit better specification of the model. So in linear regression, the relationship between the dependent variable and the independent variables is best described using a straight line. So we all know the equation of a straight line. It looks something like this. Y is equal to A plus B into X plus E. So here, Y is the main outcome variable or dependent variable. A is something known as an intercept. B is referred to as the slope of the line. X is our independent variable, and E is a new term that comes about in regression analysis, and it is called the error term or the residual term. The reason why the error term exists is you can never purely predict the dependent variable. There is no model that is so perfect that can fit it so perfectly that there is no error in the prediction at all. There is always some amount of error, and to account for that, we use the small error term, sometimes also referred to as a residual. So let us assume we have the data points collected and the university, and it looks something like the picture in the bottom left. So you have university grades on the x-axis and you have average income on the y-axis. And you notice that the data points are spread like this. As the university grade increases, seems to be a trend of increase in average income. Using this, I can make an approximation. You know what? This is definitely linear regression. So let's not bother about anything else. And we'll try to fit a best fit straight line that relates the university grades and average income. So I run the regression model. You can run it on different tools like Stata, like R, in SAS, in Python, wherever you want to. And when you run it, you get the best. it approximates a line that relates the university grades and average income. So the tool itself calculates it. The actual way the tool calculates it is by trying to reduce the mean square error between the fitted values and between the actual values and the predicted values. It tries to optimize this process of reducing the error between the prediction and the actual data point. So that is not important for us because everything happens in the back end. A simple command will run most of our regressions. So we do not need to go into the details of how it actually fits. But in the end, once it fits, our work begins. So now we have the line, the fitted line, and the line will read something like this. Average income equals to 150. It's something like this, 150 over here. It's a little less, maybe 120 plus 250. So there is each point increase leads to a 250 increase in the average income plus 15 into parents' income and so on. So in our case, over here, we are just concerned about the university grades. These are all parent income is a confounding factor. So we do not consider it. We are assuming it's kept constant and we will leave it out. We will use it, of course, as a control variable in our model, but in our interpretation, we are not really bothered about it. We are not trying to infer anything from this variable. We are just interested in this. So basically, this relationship tells us that a point increase in university grade increases the average income by 250 points. And if average income is measured in terms of euros, then and grades are measured in terms of from 1 to 10, then as the university grade increases by 1 point, the average income increases by 250 euros. That's the simple interpretation of it. Now, of course, if you have assumed that the points aren't so nice and linear, but rather they have some sort of a logarithmic curve, that means they go like this and then they start tapering off towards the top. Then you can fit a logarithmic value, but the interpretation needs to be changed a little bit more. It won't be the simple interpretation of 1 unit point increases the average income by 250, but it'll be more in terms of percentage increases. So this is linear regression. So now let's look at some tough words and tough points. Just keep these words in your mind. They are like no one can understand these words very clearly. So, but it's important to know this because these are the main assumptions used in linear regression, and specifically if the technique used is OLS, that is ordinary least squares regression. So the first important assumption is when you're building a regression model, your specification is correct. That means you have all the predictors, you have the predictors necessary to predict the model, and you do not have unnecessary predictors as well. Oh wait, I think I see a question. Okay, I can't answer that question. Oh, it's Eurus. Okay. Okay. So anyway, so first thing is we look at the correct specification. So why is it important for correct specification? Well, suppose you build a linear model and it shows this really beautiful relationship, 250 and average income. But then you realize that actually average income is very poorly predicted by university grades. That means even though uh, there are so many other unknown variables, that those unknown variables could in fact reduce the effect size of this university grades. So a correct specification means that you have most of the predictors which are sufficient to build a model, and that is sufficient to predict the dependent variable. So the way we figure it out is by checking how much of variance is explained in your model. So the dependent variable has, suppose you are able to explain 0.1% of the variance of the dependent variable, then the model is not really great because there are so many unknown variables in the model that it just doesn't make sense to make any sort of prediction out of it. There could be some other way, variable that is reducing the value. There could be something which is totally skewing there could be a variable that is totally skewing the value and so on. So ideally, you would want variance of at least 20% of the dependent variable. The way we measure that is by certain things like adjusted R square, the information criteria, AIC and BIC, and so on. So first, correct specification, ensure that sufficient amount of variance of the dependent variable is explained by all the predictors in your model. So that is number one. Second is strict exogeneity. So here the most important, here the thing is, you have not missed out a very important factor that is correlated with your independent variable. So basically, in our case, you remember we were testing university grades and wages. And then I said, you know what, I don't believe this model because parent income could be a confounding factor. Well, parent income is just one. There are so many other unobserved omitted variables that may exist. And strict exogeneity means that we have control for all the relevant variables which may be correlated with your independent variable. So the way it's explained in mathematical term is the independent variable is uncorrelated with the error term. The whole idea is to make the error term extremely normally distributed. You do not want any sort of the error term should not be able to predict anything in your model. It should be extremely outside of your model. That's the whole purpose of this. So what are the causes of when you do not meet the strict exogeneity concerns? The model is said to be endogenous, and the way the model become endogenous is when you have these unobserved or omitted variables, when you have measurement errors in your independent variable, and when there is reverse causality in your relationship. So unfortunately for us, there is no test for saying strict exogeneity. So the way you propose strict exogeneity is by coming as close to an experiment as possible. So experiment, we can make an assumption that it is exogenous, and we begin from there. There is no test that can be used to claim pure exogeneity. So whenever you submit a paper for a journal, uh, the biggest headache is when a reviewer says, you know what, I think this model is endogenous. There is no way you can prove that it is exogenous. First of all, there is no test. So all you can do is you can just argue. You can argue that all the important variables are controlled, and another thing you can do is by trying to mimic natural experiment and by improving your identification strategy. Identification strategy is the way your model become the way you approximate your model to experiment. So the third important assumption is there is no serial or autocorrelation. This you often have to visualize autocorrelation. Always think of a time series data. One point of time is somehow related to another point in time, and this is called autocorrelation. If you do not have a control variable that extracts this out of your model, you have something known as an autocorrelation. Mathematically, we say that the observation of the error term should be uncorrelated with each other. It need not always happen in time series data. It could also happen in network kind of data, wherein the choice of one thing is dependent on is influenced by someone else's choice. So in those cases also you get autocorrelation. So how do you control for this? You need to figure it out, and you need to add the relevant controls for it. And the last one is there is no heteroscedasticity. So basically, this is also similar to autocorrelation. It assumes that the variance of the errors is sort of consistent for all observation. That means there is a pure random sampling of your data. These two assumptions together are called the IID assumptions. You might have heard of it. It's called all observations are independent and identically distributed. Basically, in essence, these two means that you have done a random sampling of your sample is sufficiently random, and there is no systemic bias in your selection of sample itself. I know I am only worried about talking about these terms. So you do not need to know them in detail, but just keep these words in mind. They are at some point when you take behavioral research further and when you want to establish causality, these are some of the four considerations that you need to check if you want to make the claim of causality. So let's go to the illustration. I don't know how much time I have. One sec. Okay. So yeah, I have like about half an hour. That's great. So do you have any questions? I'll move on to the last part, the illustration. Okay, I, let's move on to the last part and wrap it up a bit. So for the illustration, I take the context of open source software development. You know what most of you should know what open source software is. It's software like Linux, Apache, Python, and so on. So in open source software, there are two types of contributors. There are contributors who can make direct changes to the open source software. They're referred to as core contributors. And there are contributors who cannot make direct changes to the source code of the software, and they are referred to as peripheral contributors. So the workflow of open source development happens something like this. A core contributor can make a change directly to the main project. A change is often referred to as a commit. But a peripheral contributor, if they want to make a change, they need to submit the change, and a core contributor is responsible for peer reviewing and evaluating the change and actually committing it to the main project. Now, the thing about this is when you say open source software, you think that everything is open. In fact, the first word of open source software is open. But why are these restrictions existing? Why should we not be able to write directly to the main project code? So you have this interesting question. On the one hand, you would assume that the open source community favors openness to the largest amount of extent. But at the same time, you have literature that comes from governance of communities that says that, restricting access to the main common pool of resource or to the common software is actually beneficial because it protects it from certain things. So you have this interesting question, like the question is, uh, does access restriction have a positive influence or negative influence on the survival of open source projects? That means, suppose you have two projects. One project has a greater proportion of core contributors, and the other project has a lesser proportion of core contributors. Everything else is constant. Which project do you think has a higher chance of survival? So the reason why survival itself is an interesting dependent variable. There are many dependent variables we can study, but survival is really interesting because it's very unique to open source. Like most software projects, commercial software projects have end goals, milestones, and so on. But software projects are actually defined successful when they remain alive for the longest period. Linux, the first release was in '91, and it's still going on after 30 years. So it's that's a sign of success in open source communities. So the main motivation for the research was that there is some sort of mixed results and understanding. Open source ideologies suggest openness, but um, uh, community research from communities of practice and governance, etc., say that access restrictions are in fact important for projects. So then I add another research question saying that how does organizational ownership moderate this relationship? So you asked what there was one question in the beginning, like how do you create new knowledge? And this is a nice way, nice way to create a new knowledge by adding a new contextual specification. So everyone, when they're thinking of open source, they are thinking about communities. But what happens when organizational own open source projects? Does the relationship remain the same or does it change? So this is how I create new theoretical contribution here. So the relevant theory are coordination theory and the theory of network governance. Do not need to know, of course, but there are plenty of theories, and you'll always find a theory appropriate for your study. So when you look at the conceptual model, it looks something like this. You have access restriction as one concept, you have survival of projects on one concept, and then you have in the middle organizational ownership, which is a third concept. And organizational ownership is assumed to moderate this relationship. It means that um, mo- uh, it means that that the direct relationship the direct relationship for individual ownership will be one, or non-organizational ownership will be one, and then will be something, and then organizational ownership will be something either more or less. So a hypothesis would be something like this. An increase in proportion of core contributors in a project has a negative influence on the likelihood of survival of the project. Notice the concept becomes measurable variables as we write the hypothesis, rather than access restrictions, which you can't directly measure. You're measuring it in terms of proportion of contributors who can make direct changes to the source code. It has a negative influence on the likelihood of the project. The, the establishment of this causality comes from the study of theory. I know that an increase in proportion of core contributors should lead to more coordination challenges, and it should lead to more variance in the contributors' expectation skills and goals. So because of these two mechanisms, I would say that it should have a negative causal effect on the likelihood of survival of the project. So it looks something like this. Proportion of co-contributors has a negative effect on project survival. When organizational ownership gets involved, I say that there is this moderation effect. The, the degree to which the organizational ownership will mitigate the negative influence that proportion of core contributors has on the survival of the project. And the reason for this kind of effect is because when organizations get involved, they bring in certain management practices that overcome coordination challenges, and they also reduce the variance in the core contributors' expectation, skills, and goals by creating these norms and by creating these culture within an organizational culture, which sort of reduces the divergence that exists in across the people over there. People feel alike when they are within the same organization, rather than when they are just rather than they're just individuals. So basically, the two hypotheses suggest that proportion of core contributors has a negative influence on survival, which is and this influence is mitigated by organizational ownership, or organizational ownership has a positive moderation effect on the relationship between proportion of core contributors and project survival. So now we'll go at data collection. So there are several data my research design is complete, and the second issue starts, the behavioral research methods. So first is data collection. And to find data, I run a Google search and I find that there are existing databases and archives which I can directly use. One example is the GH archive, or GitHub archive, which is hosted on Google. So the site that I took you to has a database called GH archive that has complete since 2012 or something. It has every open source project that was started on GitHub, and every event or every contribution that's made on the project has been logged and archived in this database. So this is one place I can get the data. Another way is by using the web API service, like I showed you before. So I use two API endpoints. One is a search endpoint to figure out what projects I want to study. So I make this selection. It somehow needs to be very random. You need to have a random sample of projects that you want to study. So I just assume projects that started between 2016 January and 2000 February January. They have more than four. They are more than most 4 stars. That means they're reasonably popular, and they're more than 4 stars and one fork and so on. So then if I use the if I run the API call, or if I go to the endpoint, it'll look something like this. So the data will, the search results will look like this. There are a total of 16,848 projects. And I know the name of the project. For example, this project title is Children Test Game. And the description is in Chinese, I think, I don't know. And you have other details about the project. And you have the number of contributors, number of commits, and everything else that you need for your research is available over here. Of course, there are more endpoints that you can use to collect more and more data. Suppose for individual data, you find that there is a confounding factor the that is the number of contributions made to the project, which is a very important confounding factor. Then I can collect it by using another API endpoint, which looks like this. So in our case, the dependent variable is survival, and I measure it by studying when the last contribution was made. And the independent variable is ratio of number of contributors who are core to total number of contributors. So here the regression model that I use is called a survival model. It's not exactly a regression model, but it's close enough. It has its own benefit when you're doing survival analysis, but I thought this is a nice example as well. So basically over here, the dependent variable becomes likelihood of project inactivity. It's actually referred to as hazard rate. The dependent variable in survival models, the dependent variables are called the hazard rate. And you try to predict what increases the hazard rate of the project. Hazard rate is the likelihood a project becomes inactive at time t, given that it has survived till time t. So here for us, I run the test and then I run the regression analysis, and I find that the proportion of core contributors in my full model has a positive influence on inactivity. That means the survival goes down. Note that the dependent variable is inverse of survival. It is hazard. It's actually measuring the hazard. So it negatively influences the survival, and the proportion of core contributors has a positive moderating effect on the survival, or it negatively moderates the hazard rates. So here, there are a lot of other statistics that needs to be reported, like adjusted R square you need to report to show that the model is sufficiently well specified. And then you also need to specify the confidence intervals to figure out if the relationship meets the 95% confident interval that is often required for behavioral research. So and then the last part is to interpret it. So a basic interpretation looks like this. As the ratio of core contributors increases from 0 to 1, the likelihood of inactivity increases by 21%. And when when projects are owned by organization, the likelihood of inactivity decreases by about 10%. So both these relationships are found to be satisfied in our model in this example. So this is basically how this is a very quick summary of regression of the regression models and behavioral research design. Just to summarize, we started by trying to understand what behavioral research is, and then what are the key considerations for behavioral research design. Then we looked at some of the steps involved in behavioral research methodology. They include data collection, measurement, and finally modeling and analytics. Then we looked at each of the two big steps, data collection and measurement, and then modeling and analytics. So yeah, that's all I wanted to say. I in fact thought that I had more slides. In fact, I thought I would run out of slides. So I think I'm well within the time. So so I will be very happy to take questions if you have any, or Maybe, yeah, if you have any other concerns or suggestions, you can also let me know. Okay, great. So yeah, I think, as I said, I want to add one caveat again. I've not gone in depth, but I've covered a lot of breadth. So these are even if you do not understand, it's fine, because the whole purpose was to introduce these terms and to let you know they exist when you do behavioral research. If you want more details, it's best you start your research, and then as you face these issues, you try to tackle them by doing further research or by going through literature. Another intention of this research was to kind of push behavioral research to you as well. It's if you do not have internship, or uh, if you're really concerned about your thesis, this is a really good way to do research. I do not have any internship. My whole PhD was not based in a company, so I did it all by using behavioral research. So do not think that it's uh, it's it's lower or anything like that. You can have equivalently good thesis by using behavioral research and public data sets, which are very, sometimes it's very easy. It requires a really nice thinking and a very novel relationship, but you can really create good research out of by studying public data sets. There are plenty of data sets available. You can create new and novel relationships using those data sets. Of course, you have to keep in mind some of the concerns that I talked about, which you can go in detail as you take the research forward. So yeah, that's it. Thank you, everybody. So I will share the presentation and I will share the recording as well. So go through it if you need to refresh something, and if you have questions, please email me, and or you can just yeah, you can email me or message me or whatever, and I'll try to answer it to the best of my ability. Okay. Thank you.